Alright, well, hello everyone, and we're back after a nice long break. I've been out in the Commonwealth of the Northern Marianas Islands in the middle of the Pacific with an OpenROV, and we've been going around to high schools teaching students about the biodiversity of the Marianas Trench and all the exciting science that's happening down there, and taking them out on the ocean and giving them a chance to dive with an OpenROV. So if you want to see that adventure, you can go to my Open Explorer page, From Surface to Abyss, and check that out. Or you can look at the playlist that I will link to here. I'll put the playlist right here. We'll say that. So, we are back. We are back with Honeycomb, the robot that sat at the bottom of Lake George. And we've taken away the battery tubes, so those have all been removed. And I've sent them off to headquarters to take a look at because the condition of some of that acrylic was interesting, and I wanted to get some of the engineers out there's impression on what happened. So, it's now time for the main event. We are going to open up the main electronics chassis, and we are going to take a look at what's going on inside this robot and see if it is or isn't repairable. And I think that it is repairable. I think that if we spend a little bit of time working on this robot, we'll be able to fix it back up. So, let's dive in. I can see there's been a tremendous amount of corrosion on some of the terminals on the DB25 connector, but that is not potentially fatal. So, let's take a look at the camera first. Here's the camera housing. You can see it's in pretty good shape. I can see some shorts down here, down where the lasers connect, some shorts down where the light boards connect. I think we can fix those. No problem. If we flip it over, the USB cable looks a little battered. A little bit of corrosion, but it doesn't look like any of those terminals have shorted. And it doesn't look like there's anything significant on the Beagle board. The Beagle board itself looks just fine. I don't see any obvious damage on the Beagle board. I do see a little bit of corrosion on the DB25 male end, as well as on the DB25 female end. But like I said, I think we can fix that. I think we can go in, do a little bit of scraping, and break those shorts. And I don't see any problems on the control board. So, what I'm going to do, I'm going to pull out my tools, and I'm going to separate all this stuff so we can really get a good look at what's going on. Alright, first thing we're going to do, pull off that beagle bone. Now the OpenROVs, the 2.8s, 2.7s, all the OpenROVs are powered by a beagle bone black. Is that focused? That's focused. And looking at this beagle bone black, so any shorts that would have happened in the system as it flooded would have happened before it reached the beagle bone. And I'm actually looking at this, and this looks, I mean, it looks pristine. If I held this up next to another totally unfazed beagle bone, I don't think you'd see any difference. I will probably power this up just to see if it boots in a little bit. But beagle bone, the main brain of the computer, it looks fine, and that's good. Beagle bones are one of the more expensive components in here. Next up, we'll undo these RJ25, RJ45 connectors. Take a look at them. Totally fine. Nothing has happened to that. Underneath here, this is a communications module. And it looks like there's some spiderwebs growing on it. It's been sitting somewhere in storage. And it's got some static shields on it to prevent anything from coming in contact. And again, you know, I think what happened was the tether was separated long before the housing actually flooded. So I don't actually think there was any power going through the system when it flooded, which is good news for us, because what we're then dealing with is corrosion rather than a short. So the communications terminal, the home plug adapter component, also looks good. And that brings us to the main part of this whole thing, the control board. And if we look at the control board, what we're looking for is any little shorts in any of these contacts, especially around the ESCs that are going to be powering the motors, and then looking down into this terminal. And once again, I really don't see any significant corrosion. If you look, you can probably see a little bit on these little wires. They're still pristine. There's not even any oxidation on these wires. So I think what we're looking at is a pretty good unit. It's certainly not a fatal unit. So I'm going to take this control board off, and then we're going to poke around inside the DB25 terminal, and then we're going to go on and take a look at this light board. So once again, I'm going to find my screwdrivers because apparently I can't keep track of screwdrivers. Okay, here's our control board. Once again, you know, I don't see any obvious damage on it. The back looks fine. I don't see any major shorts. I don't see any major corrosion. The front looks fine. The only place where there's a real issue is, you can see it inside this DB25. And, you know, that looks like corrosion that happened after the fact. And I can even kind of scrape it off. So I've got a pick. And I'm just going to kind of scrape around and see if this is kind of permanent corrosion or just a little bit of oxidation that happened around the power terminals. And it looks like it's just a little bit of oxidation happening around the power terminals. It doesn't look like there's any major breaches, no major shorts. We will obviously be very careful when we power this on for the first time, and we'll probably power it on low power. But if you look, it all looks really good. So far, all the electronics look like they're in pretty good shape. They'll all need to get a little bit of a test done. We'll check all that out. But now it's on to the camera housing. And the first thing I'm going to do is I'm going to take the camera off this pivot. Okay, we've got our light board. It does look like there's been some corrosion around these terminals. But it all, again, looks like surface corrosion. It scrapes right off. So we're just going to go through these, and we're going to scrape off some of the surface corrosion. And then it's hard to tell with the USB plug what's really going on inside. So, you know, I think this one's probably fine. I might plug it in just to see if the camera still functions, and if the camera still functions, we'll go ahead and go from there. But that is the electronics. So we have now gone through the main battery system, the electronics chassis. The motors will obviously all have to be replaced. There's no way around that. And everything looks as good, if not better, than expected. Actually, let me do a little scrape on this just to see. It's kind of like being a dentist, you know. You just kind of go in where there's plaque and just scrape it off. I might want a wire brush for some of this. But again, these terminals, they look pretty good. You know, it's a little rusty, but I'm not too concerned about that. Feels like there's a good contact in all of them. We can always go in with a multimeter and probe them out later. So, the electronics are good. The last thing I want to do before I end this video is I just want to take out these O-rings. I want to take a look at how some of the physical hardware fared. So these O-rings will be replaced. We're definitely not going to keep the same O-rings, so there's not too much of a worry about damaging them on removal, but let's pull them out anyway and take a look. They're in pretty good shape. They're still pliable. They've been in the water for a long time. They've been through a couple of freeze-thaw cycles. Obviously, as you know, sometimes when O-rings freeze, they become damaged beyond repair, so we wouldn't risk putting these back in. But as a general overview, they seem fine. You pull out the syringe end caps. I seem to remember this one being a little finicky with the syringe end cap even before it sat in the ocean for a long time. And it's still finicky. I might have to probe that out. That doesn't look too sharp. So there's your syringe end cap, and again, looks fine. There's not any surprise there. The epoxy seal around it still looks solid. Again, this was a very well-made robot to begin with. It was built for a Maker Faire, so this isn't one I would expect to have a lot of superficial damage. And then we're going to bust this open. This is pretty well solidly stuck. I imagine we might see some damage on this O-ring just because it's been compressed for so long. And let's just massage that out there. But you can feel the silicone grease has kind of become very tacky. So, I don't know. I might actually go ahead and try to revitalize those O-rings. I don't see any reason why we shouldn't try to bring them back to life if we can. Same with the silicone, or the rubber end caps, the syringe caps. I think we might be able to get something out of that. Okay, so that's all for this installment. I'm going to go ahead and clean up a bunch of this hardware. I don't think you guys care about seeing that. And then next time, we're going to pull off all the motors, give everything a good, solid going over one more time, and then we're going to start building it back. The folks down at OpenROV HQ have kindly donated all the equipment that I think we'll need to get this thing back in operating order. So we are finally about to begin the rebuild. Until next time, I'll see you all later, and happy diving.